Welcome to Module 4, where we're going to be discussing planning based on the different server roles you can have with Splunk. We're going to cover speed and performance, as well as all of the different Splunk server roles that currently exist that you can deploy out, and introduce some new terminology that we may not have heard before for Splunk server roles that you can have. Diving right in, we can start with the discussion about thinking about what sizing questions to ask when we're considering our deployment. So starting at the bottom, we have our forwarders, our universal heavy or intermediary forwarders. That is where all of our data is currently coming into our environment and going off to be forwarded to the indexer layer. So how much data in, as we've discussed, is an important item to know so that we can expect the amount of volume coming in and account for that. How many endpoints are currently in this environment? What operating systems are coming in? How are they being parsed or searched? Where is that workload going to take place for the amount of volume coming in? Next, how much data will be stored on each indexer? As we discussed in the indexing and indexer mod, it's going to be largely determined on volume, retention period, and how fast you want your searches to be performed. What will our users need to be searching in the org as we go to the top layer involving user search capability? Are users going to be searching a lot, a little? Are they using real-time searching? That's going to be pretty taxing on our performance, and we may need more indexers to accommodate for that performance. Are they barely searching? Are they using Splunk as a main detection tool? What are our users going to be doing? And do we need acceleration? Is the environment leveraging data models? Are they using summary indexing? Are they doing report acceleration? All of these things are going to affect sizing and performance and search capabilities. So we need to encompass all of these at the layers of the data coming in, at our forwarders, to our indexer layer for where the main searching performance is going to be affected, to the search head layer and our user layer to determine use cases based on what the users are going to be searching and how frequently. Lastly, what apps or technology add-ons do we want? Are there going to be apps running in the background that are conducting searches, or do we not need to be concerned with that? So kind of just put up this slide as a general 6 questions to keep in mind and breaking it down by each layer from the bottom up to try and determine what kind of sizing questions to ask for your deployment to get an idea of how you're going to scale and what your resources that you need are going to look like. Now we can introduce IOPS. IOPS stands for Input Output Operations per second. It's basically a measurement of the number of operations that can be performed by a storage device in a second. This is going to be measured in disk throughput, your read and write speeds, and you should be prioritizing this for where your data is going to be searched the most frequently, that being our hot and warm buckets. So you want to have higher IOPS for your hot and warm buckets than you would for your cold buckets, and definitely not concerned about IOPS for your frozen buckets, as those are non-searchable and they're just going to be sent off for long-term storage. So really this should be applied to thinking about, how can we search our buckets faster, mainly thinking about hot and warm buckets. And Splunk requires high IOPS to efficiently process and index the data. It's a critical performance metric that affects the speed and efficiency of search and indexing operations. It's going to depend on several factors, including the amount of data coming in, as we've discussed. Data volume is the largest factor, and user searching that data is probably the second, and then also retention period. And then also the hardware configuration. Are we going to leverage a storage hardware that's designed for high performance, like a solid state drive, but that may cost us more money, or a high performance hard disk drive? Comparing the two, figuring out which is a better cost benefit solution based on the slide before for all 3 layers that are in play. determining or presenting the client or customer with different options for how they can increase their IOPS based on their budget. And to monitor the IOPS in a Splunk environment, it provides a built-in IO performance dashboard that displays real-time IO statistics and performing metrics. You can find this in the monitoring console. In addition to monitoring IOPS, it's also important to monitor other performance metrics such as CPU utilization, memory usage for the amount of RAM that you're using, your network bandwidth. Generally, all Splunk server roles, we want to have in between those layers about a gig bandwidth for network traverse traffic, and ensure that the entire system is performing optimally. That's all that information can be found on the monitoring console, and you can drill down into that specific instance and look at all those statistics there to see if you're over utilizing your limitation on your hardware or if you're underutilizing it, and you can adjust and scale from there. But basically, the largest concept that we want to be aware of with IOPS is we want to have low latency for the network, which means higher bandwidth. And we also want all of our devices to be synchronized in time. So it's very important that all the server roles be incorporating NTP, your network time protocol, so that everything is deployed out and synchronized across time. So the minimum bandwidth, again, 1 gigabit per second. You ideally want your search heads to search heads communication, if you're in a search head clustered environment, to be less than 200 milliseconds. Your indexers, if those are clustered, those communications between the search peers should be even faster, as that's where the searching and performance is going in. So maybe less than 100 milliseconds for your IOPS. And you want the highest amount of bandwidth between your indexers. You can kind of have a lower bandwidth and connection speed for the data going over from your forwarders to the indexer layer, and kind of a standard one for users to your search head. But the most important is going to be your indexers communication between each other and at the indexer layer. Now, building off what we just said, it's helpful to put this in the chart again and highlight with the green and yellow where speed is most important. Speed is going to be most important at this green layer here for when users query the search head to perform their searches. The speed and IOPS and latency that needs to be the highest is the communication from indexer to indexer if they're clustered, and also the search head to the indexer layers. When you build your SPL and you put it into the search head, it immediately is going to go out and find the indexers where the data is retained, and we want the searches to be returning results back as fast as possible. So we always want to think of our indexer layer as our main focus for solving any type of performance issues for searches running longer than expected, dashboard panels not populating the data quick enough, and then we can also move into other kind of ideas to think about why searches are running slow for acceleration, summary indexing, and data model acceleration, things of those natures. So the yellow areas here, you can kind of have more wiggle room to have lower speed. I mean, the speed should still be acceptable, but it's not as important as the green layer here. And the sizing for searching that we want to consider is the number of searches that users are performing, the number of jobs that are running, apps that may be running searches in the background. If we're using acceleration to speed up our search time to completion, and we also want to stay flexible and figure out if we need to scale horizontally by adding more indexers to increase our performance, or scale down and reduce the number of indexers to save money, cost, and budget considerations. And one thing to note is that at the forwarder levels, you can incorporate auto load balancing to kind of accommodate the load that way and go into scaling that way so that your forwarders can route to any of the indexers based on load balancing. This is a configuration that's set on the forwarders to have a better pool of data flowing into your environment spread across more indexers, and it lowers your risk for creating bottleneck environments or the data pipeline getting backed up. And another thing we want to think about for storage requirements for the indexer, that's primarily going to be determined by the size of your indexers, the storage requirement based on the operating system that the indexer is running on, and whatever configuration files you're putting on top of it. We also want to consider, again, if the indexers are clustered, what the search replication is, the search factor, and retention policies, and if we are accelerating or not. Moving into this slide, we might be introducing some new terminology for server roles that you haven't heard of before. But starting at the top, we have our license master, and this is basically going to keep track of your license using statistics. So it's going to allocate your license that you've purchased with Splunk, configure and manage your license usage across all of your instances. You only need one license master for your deployment. Everything else can be a license peer that when the data is being run across and charged against your license, it will report that utilization back to whatever Splunk server you have dedicated as your license master, and it will keep track of your license pools, violations, and warnings, and how much licensing you're actually using based on the license that you've purchased with Splunk. You also have your deployment server on the bottom left there. This is going to be your basic server that's going to manage all of the configuration files for your deployment clients, which are all of your forwarders that are out in your environment, whether those are heavy forwarders or universal forwarders. The deployment server is basically going to manage all of those configuration files, and when the deployment clients, the forwarders, phone home to the deployment server, they will pick up those changes within the configuration files for the apps based on the server class that they're in, and they will receive the updates that way. So your deployment server, think about it as what's going to manage all of the configuration files on your remote instances that have forwarders deployed on them. The deployment server makes it so that you can scale your environment. If you have 10,000 forwarders out in the environment, it's not realistic to go to each one by one to edit the inputs or outputs.conf or change the settings on all 2,000 of your Windows endpoints. You would just do this through the deployment server, go into your Windows server class on the deployment server, edit the configuration files there, and then when those Windows endpoints phone home to the deployment server, they'll pull down the latest changes to the configuration file, and all 2,000 will be updated at once. So you're going to be doing a lot of work with your deployment server in large production environments, and it's pretty standard operation for managing your forwarders. The master node on the right here, this is going to regulate your index environment if your indexers are clustered. So you're not going to configure each indexer in a clustered environment. That would be redundant. If you can manage and configure the entire index clustered environment from one central location, we're going to do that, and the master node is how we accomplish that. We also have the deployer. The deployer on the right top of the screen here near the search heads, this is going to distribute configurations to your search head cluster members. So if you have the master node for your indexers that are clustered, you have your deployer for your search heads that are clustered. Again, we don't need to go into each individual search head and manage the changes. If they're clustered together, we can use a central point of management for them to conduct all the changes and push it out to all 3 or 4 search heads that we have in a clustered environment and deploy them out that way. This slide is actually not accurate. It's a mistake on my fault. You need at least 3 search heads to be in a clustered environment. So I should have put 3 up there looking at this slide, but the deployer only needed if those 3 search heads are going to be clustered. So some new terminology here that you may not have heard before. And we also want to consider not mixing server roles with each other. That would just be disastrous. So on the top right, I put up there, we never combine an indexer role with a search head role. So All of these different server roles that you have are going to be running the same Splunk Enterprise software that you download, through your wget command on Splunk.com's website for the download of Splunk, and then you just go into the monitoring console and change the type of role that that server is going to have. So the packaging for downloading and running Splunk is all the same. The only changes based on functionality come from what setting you apply to that bundle through the monitoring console. So you'll go in there and check, hey, this is going to be my search head and my license master and nothing else. Then on your next server that you download the Splunk Enterprise package to, you go into the monitoring console and say, hey, this one is just going to be an indexer and nothing else. That's the only difference from a settings perspective that define your server roles. You're not going out and downloading a Splunk Enterprise package that's for the search head or for the indexer. It's all the same binary, just a different setting configuration that you make on the monitoring console to allocate the server role to that binary. Lastly, for sizing on the slide, just want to touch on some of the CPU, memory, disk, and network, and kind of factors that can come into play here for sizing. So for the license master, you kind of don't really need a high performing license master for CPU, RAM, or disk space. It really just depends upon how many license peers you have in the environment that are sending data for that license pool back to the license manager, but really it's not that big of a difference. So you can save money and not have a massive high CPU RAM machine running on your license master. Just kind of keep those settings on the lower end to save cost. The deployment server, maybe you want to do something medium for CPU and RAM, depending on obviously the number of deployment clients that are out there, the number of applications you're storing on your deployment server, number of configuration files that you have on there. If you have more or less, you should scale up or down depending on the size of your environment and the number of apps you're storing on your deployment server. The master node, it doesn't really need a whole lot, but you don't want it to go too skimpy. So maybe something, again, medium range, depending on how many indexers you have out there. Are you managing 4 indexers or 20? Scale appropriately. And then for your deployer on the top right, that really doesn't need much. You can set it to pretty low utilization or low specs for hardware needed for CPU, RAM, disk. And then everything as a whole, you kind of want to have that 1 gig of network bandwidth will suffice for all of these roles. Just a quick note here on diving in a little bit deeper to the search head specs that you would want. Just putting on the left here the reference for the previous module of covering the indexer specs for hardware, and on the right kind of the changes in blue for your search head. Generally, it's going to need more CPUs than the indexer because of the number of search requests that you're going to have. It's going to take 1 CPU core per search request for your users. So you want to think about all the users you have searching and what type of searching they're going to be doing. If they're doing acceleration, if there's apps running searches in the background, how many users are going to be running real-time searching, etc. All those things play a massive factor in your scaling for the specs that you need to assign and allocate to your search head. But generally, it's going to be the same Intel 64-bit architecture for Linux or Windows operating systems, the gig network interface bandwidth, and for CPUs, we'll do 16 physical or 32 virtual at 2 gigs or greater for speed per core. RAM can stay about the same for 12 gigs of RAM. And the IOPS, it's really going to depend. If you have a higher ad hoc or scheduled search loads, maybe you want to use a solid state drive, or you should really stay no less than 800 IOPS, and the search head requires at least 300 gigabytes of dedicated storage space. So just wanted to put this slide up as a good reference for comparing. And basically, the most important thing to take away is your searches that are going to be performed. You need to consider how many CPUs you're going to need, generally 1 CPU core per search request, and just think of the search head needing more CPUs than the indexer. kind of keeping the other stats very similar, and you'll be good to go. One more item to note for this module is how you want to plan your deployment by testing. So I have 4 main topics here to discuss, and we always want to test and plan and then push out our plan for changing the production environment at an appropriate timeline that works for your use cases. So performance testing, staging and testing environments are going to allow you to get familiar with the data that's coming in, help you identify any bottlenecks or issues that could impact your performance before pushing to a production environment. It's going to help you optimize your deployment and ensure that it can handle the expected volume of data and users searching that's occurring. This will help you do your capacity planning. If you do a stage and testing environment or like a sandbox environment to evaluate the capacity and hardware of the infrastructure, you can then see if that expected deployment is going to handle the amount of volume and users. This can help you to determine if you need to scale up or if you can scale down before you put all of these massive changes into the one plan that you made and it turns out it wasn't right. This is why testing comes in handy. Your hardware considerations, as we mentioned, figuring out the right CPUs, RAMs, IOPS that you need, all is going to be beneficial and prevent you from over or under provisioning your hardware that you need. And lastly, it's going to reduce risk. By testing your Splunk deployment in a simulated data or staging environment, you can reduce the risk of issues in downtime, production environment, help you cut down on cost, reduce data loss, or other issues that can impact the client's or your environment's operation. So how long you want to test, how many test indexes, how many test server roles you want to do is all up to you. Kind of with testing, do it as real as you can for what you're going to be pushing to prod. So if you're going to run Splunk 9.0 for all of your server roles, test with Splunk 9.0. It wouldn't make sense to test with 8.0 or a different revision of the binary that you're using for running Splunk. Do the same apps, the same users conducting their searching, the same data sets, and it'll just set yourself up for a good level of success. So yeah, test your inputs, test your configurations, test your performance, and then change it in your test environment to then get it to a point that you're satisfied with, and then use that as your exact deployment for pushing out for solutioning your client's environment. Moving to the demonstration here, just going to cover some good documentation for hardware referencing, references you can have on the Splunk docs for what storage solution you should pick based on the server role, and a summary of performance recommendations as well. I'll see you there.